So today we will cover the Maxwell fourth equation, which can be also stated as the Ampere law. According to Ampere law, the line integral of the magnetic field of induction around any closed path is equal to the absolute permeability of the space times the current bounded by the path, which can the equation can be stated, or the equation can be stated in simply as the changing electric field produces the magnetic field. Okay, so whenever there is a change in electric field, it produces magnetic field. That was the statement by Ampere. But later Maxwell added the term id. Okay, at the right hand side of the equation you can see the term id, which can be stated as the displacement current. Okay, so this was the term added by Maxwell, and which this term was not present in the Ampere law. Okay, so Maxwell referred this second term on the right hand side, and this the changing electric field term as the displacement current. So this id means what? Displacement current. So let me explain you what this displacement current is. So this was an analogy within dielectric material. You are aware of the dielectric material, and if this dielectric material is placed in an electric field, the molecule will get distorted. Okay, so their positive charges moving slightly right and the negative charges slightly to the left, which we can call polarization also. So now consider what happened to the dielectric in an increasing electric field. So if you are increasing the electric field, the positive charges will be displaced to the right by continuously increasing distance. So as long as the electric field is increasing in the strength, the charges are moving, and if there is a charging or charges are moving, then you know that whenever there are charges move, there is something current. So we call this current as a displacement current. And at the same time, the negative charges are moving the other way, but that is a current in the same direction, so adds to the effect of the positive charge motion. Okay, so that is in the same direction. So the Maxwell's picture of the vacuum was that too hard that the dielectric properties somehow he pictured a similar motion of charge in the vacuum. So we have just described dielectric, but this is why the changing electric field term is often called displacement current, and in Ampere law it was just added to the real current. So this was the Maxwell fourth equation. Maxwell just added id as the which was the right hand side, which was the term on the right hand side of the equation, that is the displacement current, and we are seeing what this displacement current is. Okay, so this was the Maxwell fourth equations. So with this we have completed all these four equations of Maxwell. Maxwell has completed a number of calculations, and he was supposed to be the master of this all the equations and the electromagnetic field. Okay, so today we will stop with this, and this series of Maxwell equations will complete with this lecture. Thank you.